Hello guys, welcome back to my channel. Mason African Motives are still working on mathematics O level. So in this case we shall be focusing in this class actually on the gradient concept and the equation of a straight line. So this is another part that I discover that most of you guys, you're actually facing some challenges when you're working with equations. Sometimes you are actually working with quadratic graphs or cubic graphs. Then there's a need for you to calculate the equation of a straight line, or you are working with a linear programming. There's a need for you to calculate the equation of a straight line. You are working with transformation. You want to calculate the equation of a mirror line. You want to use actually the equation of a straight line. So it's a major part that plays a role in your mathematics that you need to understand its basics. All right. So actually what we have here on the straight line. When you are given a straight line, there are two properties that actually happens here. I'm just going to explain from a normal straight line. You'll be having points on a straight line. So a point, actually a straight line, there are points which were joined together in order to produce the straight line that you're given. So these points which are on a straight line, when you take any of these points and calculate the gradient of that line, the gradient is going to be the same. So actually, this gradient that we are saying is the same. What do we refer to as the gradient? We know that gradient is simply is the steepness of what? Of the slope. So it's actually, we can write this as the gradient is equivalent to the change in y over the change in x. Change in y over change in x. So there's a change that is happening in y. So here I'm not actually talking about a graphical presentation. I want you to understand what is the gradient and how you actually work with the equation of a straight line. So we know that when you are given on a Cartesian plane like this, a Cartesian plane consists of what? Of x and y, and this will be your straight line. So the gradient, that is the steepness of the what? Of the slope, which is a change in y over a change in what? In x. So you'll be given actually 2 points, or you can be given a consideration of a diagram like this, but definitely you can take 2 points from that. Okay, so how do I determine this gradient? You'll be given 2 points. So given points, let's take the first one is x1 and another one is x1 y1 and another one is x2 y2, like this. These are the points that you're given. This gradient that we are referring to as the change in y over change in x is going to be given by this formula. Gradient is equal to y2 minus y1 over x2 minus x1. That is the gradient. So we are going to use the letter m later on when we are now referring to a straight line to indicate or to represent the gradient with the letter m. But for the meantime, you're just writing the normal way gradient is equal to. So what I'm simply saying is that when you are given 2 points like this, sometimes they can just give you 2 points, minus 1, 0. And 2, 7, like this. These are 2 points that you are given and you want to calculate the gradient. So how am I going to calculate the gradient from this concept? Remember, we said the gradient is the change in y over the change in x. So it's going to be gradient is equivalent to y2 minus y1 over x2 minus x1. I have to write my formula. So not to make any mistake, guys, make sure that you just indicate this is your x1, this is your y1, this is your x2, this is your y2, like this. Okay, so now you can substitute here y2, which is the value of y2 is 7, minus y1, this is the value of y1, it corresponds with a 0 there, so it's 7 minus 0 over x2, which is the value of x2 is 2, minus x1. Take note, your x1, it's a negative, so it's going to be -1, like this. There's a negative for the formula and the negative for x, so it's minus x. Okay, so if you are to simplify this further, that's 7 minus 0. 7 minus 0, there's no effect, it's just going to remain as 7 over 2 minus 1. So minus and minus, that's a plus, so it's 2 plus 1, which is 3. So gradient, actually you can leave your answer like this as an improper fraction, it's fine, or you can divide 3 into 7, that is 2 and a 1, a 2 remainder 1 over 3, so it's 2 and a third. So that is what you're going to have as the gradient there. All right, then what about the equation now of a straight line? How am I going to determine the equation of a straight line? So there are actually conditions that you can use, and some of them, guys, is actually not a matter of to apply them. There is this part that is being used that you can actually write this y minus y1 over x minus x1 is equal to gradient. Yes, you can use this concept, guys, but guys, now with the time that we are moving with and so forth, you find out that what you are doing is a lot of that you're working with. So how can I actually reduce this overload of working with these formulas and so forth? I can just actually use this concept. Whenever you are given to find the equation of a straight line, you know that the equation of a straight line is given in this format of y is equal to mx plus c, where this m represents the gradient and this c is the y-intercept. Actually, when you're given the y-intercept, it can be an advantage to just substitute the values, but in that format, that is what it represents. So I can actually find this. Sometimes they can give you a condition where you are given to have the equation of a straight line given a point. Let's say you're given a point, and gradient. So if you are given a point and a gradient, you can actually find the equation of a straight line. Like, let's take for example, you're given the point 0,2 and gradient. You're given the gradient, that the gradient is minus 1, like this, and you're asked to find the equation of a straight line. We are talking about the equation of a straight line here. Equation of a straight line. So how am I going to determine this equation of a straight line given the point and the gradient? All right, I'm going to use this formula here. Take note, the point that I'm given here is not is the y-intercept, actually, the way that I've taken it, but I want you to know the concept that you are using. You are going to write this equation as y is equal to mx plus c, like this. Okay, you substitute the gradient because you have got the gradient here, which is minus 1. So you substitute the gradient. In place of m, you substitute minus 1. So y is equal to, in place of m, you substitute minus 1. So minus 1x is same as minus x, like that. Minus 1x is the same as minus x. Okay, that's what we have for the meantime that we can substitute. So we're going to have plus c, like this. Okay, we can just write the value of c, but how are we supposed to calculate this value of c? We are supposed to substitute this point, because we have a point which is 0,2, where x is 0 and y. Remember, a point is written in terms of x and y. So x is 0 and y is 2. So in place of x, you substitute 0. In place of y, you substitute 2. Okay, so I'm going to substitute 2 in place of y, and x is a 0. So in place of x, you substitute a 0. So it's minus 0, like this, which is actually a 0. There's nothing here. So it means c is equal to what? C is equal to 2. So by substituting the point that you are given, you are going to determine the value of c. So therefore, the equation now is going to be y is equal to minus x, this part that you obtained, plus c. And what is our c? our c is 2. So we are now having the equation of a straight line. So it's a pretty easier way that you can use. Even if you are given 2 points, you find your gradient, then you apply this method. So it can be an advantage to use because it can work in any condition, whether you are given 2 points or you are given just 1 point and a gradient. So sometimes you'll be given 2 points. So let's say we are given 2 points and you want to calculate the gradient of a straight line. I mean, you want to calculate the equation of a straight line. You are given 2 points, minus 3, 4, and another point is given as 7 minus 1, like this. And you're asked to calculate the equation or to determine the equation of a straight line. Actually, it's to determine the equation of a straight line. So how am I going to determine the equation of a straight line? Okay, definitely I have no option. I have to determine the what? The gradient. There is no option. There is no way. So just like previous part, x1, y1, x2, y2. No matter the method that you want to use, there is no way. You have to first determine the gradient. So gradient is equal to, remember I said y2 minus y1 over x2 minus x1. Always write the formula, whether you know it by head, write down the formula always. So y2 is minus 1, so it's minus 1 minus y1, which is 4 over x2. Your x2 in this case is 7 minus x1. x1 is this value, which is minus 3, so it's minus like that. Okay, which is going to give us what? Minus 1 minus 4, which is minus 5. Okay, over minus and minus, that's a plus. So it's going to be 7 plus 3, which is 10, which is going to give us minus 1 over 2, which will be reduced by 5, 1, 5, 2. So you're going to obtain minus half. All right. So the question is to find the equation, to determine the equation, and we just determine the gradient so far. Okay, let's just write what we have. We obtain the gradient. Yes, we've got the gradient now. So the gradient in this case is minus 1 over 2. That's our gradient now. All right, how are we going to determine the equation? We have 2 points, these 2 points here. So you choose which of the methods that you're going to take. You can actually use the one that I'm going to show you. You can use the one that we used the previous, because the gradient is there. Remember, we said we can use the equation of this formula, y is equal to mx plus c, where m represents the gradient, and I now have the gradient, so I can use this again, or I'm going to show you another one. So let's substitute the gradient, which is minus half. So y is equal to m, you substitute the gradient, which is minus half x, like this, plus c. So the first stage, you substitute the gradient, okay? So you substitute the gradient, okay? Then the other part, you substitute any given point, okay? So the first one is for the gradient. Then the second one is any given point. Why? Because you are given 2 points here. So you substitute any of these 2 points in order for you to calculate the value of c. So you're just going to take one, and you're going to find the same answer. So I'm going to use one, then you try this one. I'm going to work with this one. We are going to obtain the same answer, okay? So x, y, and x. So in this case, we've got x and y. So y is 4. This is the value of y, which is 4. So 4 is equal to minus half times x. In this case, our x is minus 3. This is the value of x, which is minus 3. So it's minus half times minus 3, like this, plus c. All right, so what are we going to have at the end? It's 4 is equal to minus half times minus 3, which is going to be plus 3 over 2. You're going to obtain 3 over 2 plus c. So to find c, this time you have to transpose 3 over 2. So it's going to be 4 minus 3 over 2. All right, so how do I subtract 4 minus 3 over 2? Because this is transposed now, I'm left with C. So how am I going to subtract this? There are so many ways, guys. 4 minus 3 over 2 is just means 4 over 1 like this. So we've got 2. 2 divided by 1 is 2 times 2. So it's 2 divided by 1, which is 2. Then 2 times 2, which is 8, minus 2 divided by 2, that's 1. 1 times 3, which is 3. 8 minus 3, which is 5 over 2. Okay, so the value of C is going to give us 5 over 2. So C is equal to 5 over 2. So therefore now the equation is going to be y is equal to the gradient with this part here that we obtained, sorry, not the gradient but this part with x. So it's minus half x like this plus C. Our C is 5 over 2. So it's plus 5 over 2. So when you're working with equation, you can leave your answer as an improper fraction, those fractions like that. Okay, so what is the second way that I could have used? Most of you guys, you were taught this method, so I'm just going to explain it. Maybe it can be an advantage to you. You were taught that to find the equation of a straight line, you use this formula y minus y1 over x minus x1 is equal to gradient. Yes, you can use this one. It's still one and the same thing. So this x1 and y1 is from any point. Again, you choose any point of your choice. Okay, so in this case we were given the points from the 2 points that were given already. The gradient, we know, remember that the gradient, we have got the gradient. Okay, the gradient, we obtained that the gradient in this case that was our gradient, which was minus half. Okay, we had minus half like that. Okay, then we had a point that I choose, so I'm just going to use the same point that I chose the point of minus 3 4. So I'm going to work with the same point but using this formula. Now that's another formula for you to calculate the equation of a straight line. So it's going to be, this is your x and this is your y, so it's y minus y1. This is the value of y here, which is 4 over x minus x1. Your x1 is minus 3 like this. So as you can see, it's a familiar working again, which is equal to minus half like that. Okay, you equate to the gradient because is equal to the gradient. Your gradient is minus half. Okay, so you're going to obtain y minus 4 like this over x minus minus 3. So minus and minus, that's a plus, so it's going to be x plus 3 like this, which is equal to minus half. Okay, so what am I going to do? I can cross multiply everything here, or yeah, there's so many ways I can cross multiply. Let's cross multiply and see what you're going to have. So if we cross multiply, you're going to have 2 times y. So let's just open a bracket, y minus 4 like that, which is equal to minus 1 is going to affect x plus 3. So you open a bracket so that you don't miss this. So 2 times y, that is 2y. 2 times minus 4, that is minus 8, which is equal to minus 1 times x, that's minus x, minus 1 times minus 3, which is minus 3. Okay, transpose this to the other side, minus 8, you're going to be left with 2y is equal to minus x. Minus 8 to this side is going to be a plus 8, so it's minus 3 plus 8, which is plus 5. So depending with the question, sometimes they can actually ask you to leave your answer in the form of y is equal to mx plus c. So if they ask you to leave your answer in this form, what are you going to do? You divide everything by 2, by 2, by 2. So if you divide by 2, you've made y to be the subject. So it's going to be minus x over 2, which is the same as minus half x plus 5 over 2. So as you can see, we are obtaining the same equation. But look, guys, this way, it's most of you use this method, but it's you can have a lot of mistakes, the involvement of mistakes. You're working with the equations, you're working with that, or rather you could just use that part that we used. It had lesser calculations if you cross-checked with this one and compare. So you compare you choose which one is best for you. If you are used to this one, there's no need for you to change. You have to continue using this method. Okay, so the other last properties that you're supposed to use to know, we are going to work with them on separate class with questions, but you just need to know these properties, that whenever you are working with parallel lines, okay, we know that these parallel lines is a concept like this. If I'm on the, remember we are working with straight lines here, so you're going to have maybe two lines which are parallel like this. So what do they have, or what do they possess when you are into these mathematical skills, working with the gradients and so forth? So parallel lines, you have same or equal gradients. So parallel, they have equal gradients, equal or same gradient. So which means if this is line L1 and this is line L2, it means, remember we said gradient is represented by M, so gradient of line L1 is equal to gradient of line L2. Remember we said gradient, it can be represented by the letter L. So we are simply meaning gradient of line L1 is equal to gradient of line L2 if the two lines are parallel. If the lines are parallel. If the lines are parallel. This is what you're supposed to have in your notes. This one, you're supposed to write it down. So it means that for any condition where you are given parallel, because they can give you two parallel lines, one line they give you a gradient, then another one they give you a point and they ask you to calculate the equation on that line. You have to understand this concept of knowing that the parallel lines, they have the same gradient. So it can be a consideration that you can use on many cases, and also the properties that you are supposed to know, also working on the Cartesian plane with a straight line. What are the properties that you have on the Cartesian plane, where they can ask you even to sketch a straight line? Mostly you're working with linear programming, you want to sketch straight lines, so you also need to know how to sketch straight lines. So not to miss these classes or from Mason African Motives, make sure that you become part of the family Mason African Motives by subscribing to the channel, so that anytime we upload a new video, you're going to be part of it. So that's it, guys, for Mason African Motives, and thanks for those who are being part of the family for the new time. Let's continue to share our videos to our friends and colleagues so that they also can benefit from this information, so you can change the society by actually changing the way that you give actually to them. So let's actually give more to them by sharing these videos to them. Okay, so that's, guys, from Mason African Motives. Till we meet again.